Alright guys, day 5 is on energetics. The big idea for this chapter is how to calculate enthalpy change, which is your delta H. There are 3 main ways how to calculate delta H. The first way is experimental method. So you get your delta T from your experiment, or the question give it to you, then you proceed to do 2 steps of calculation. Step number 1 is you take Q equals to MC delta T. M is the mass of solution. C is your heat capacity. Delta T is the heat change from your solution, whether it's exo or endo. Then step number 2, to calculate your delta H, you add a sign plus or minus depending on exo or endo, and then you take your Q, divide by the number of moles of limiting reagent. Second method to calculate your delta H is to take the bond energy method, which is only applicable for simple molecules with covalent bonds in their gaseous state. So you take all the bond energy of every single bond in the reactant minus all the bond energy of every single bond in the products. Okay, just reactants minus products, you will get the delta H of the reaction. So the last method is the energy cycle method. A special energy cycle method is your Born-Haber cycle for ionic compounds. Okay, so you can use your Born-Haber cycle using this acronym FAIL, delta H of formation, then delta H atomization for both metal and non-metal, and then you have ionization of the metal, and then EA for the non-metal. Then all the way you will connect it all together in a cycle using the lattice energy. Usually question on energetics, they will start off by asking you to define one enthalpy change definition. Okay, so definition is broken out into 3 parts. First part is energy change, whether is it exo or endo, just put heat release or heat absorb. Second part of it is what does the per mole refer to. For combustion, per mole refers to the substance burned. For formation, it is per mole of substance form. For neutralization, it is per mole of water form, so on and so forth. And then the last part is just standard condition. Lastly, at the end of the question, sometimes they will ask you, why is your answer not the same as the standard answer? So different methods will have different reasoning. For example, experimental method, heat gain or loss from surrounding is not accounted for. For bond energy method, the bond energy given in data booklet are just average values. Or maybe one of the reactants or product are not in gaseous state. For Born-Haber cycle, you can say that covalent character is not accounted for in the standard answer. So number 1, you need to know the standard methods for calculating delta H. Number 2, you need to know the definitions. And last but not least, you need to know the common reasons why your answer doesn't tally with the textbook answers. Follow me for more useful H2 Chem summaries.